It sounds like a cheap advertising slogan, doesn't it? But the truth is, we are actually standing right in the middle of it. Over the past 4 years, humanity has simultaneously crossed 9 massive technological tipping points. A paralyzed patient moved a computer mouse with a chip in his brain. 53-year-old skin cells were reversed to age 23, and the US ignited a miniature sun right here on Earth. If you hear these individually, they sound like sci-fi movie plots. But all of this exploded at the exact same time, within a single 4-year window. Let's look at what really begins when 9 tipping points are crossed all at once. The first clue, the mind-controlled mouse. In January 2024, at a hospital in Arizona, a quadriplegic patient named Nolan had a coin-sized chip implanted in his head. 2 months later, on a live broadcast, without moving a finger, he moved a cursor on a monitor using only his thoughts. He then played online chess and even a game of Civilization. This isn't a movie. This is a real event documented in an official FDA clinical report. The Neuralink chip uses 64 threads, thinner than human hair, holding 10 to 24 electrodes that rest lightly on the brain's surface. It acts as a bridge to pull our thoughts out into the real world. Progress moved incredibly fast. By August 2024, a second patient named Alex, a former soldier with a spinal cord injury, received the chip. He used his thoughts to play video games, and even more insanely, demonstrated controlling the hand of a Tesla Optimus robot. Remember this specific moment, because it comes back in the final chapter. A third patient who had lost the ability to speak due to ALS used the chip to edit videos. In just 4 years, the number of patients grew to 21, logging over 12,000 cumulative hours of use. Now Neuralink is preparing its second-generation chip called BlindSight, which projects video directly into the visual field of the blind in pixels. The FDA designated it as a breakthrough device in September 2024. If moving a mouse with a brain chip was Generation 1, Generation 2 is redrawing vision itself. But human expansion isn't just happening inside the skull. Remember Google Glass back in 2012? It was a hyped $1,500 sci-fi gadget that quietly vanished. Fast forward 13 years, and look at the Meta Ray-Ban smart glasses Generation 2. They look like normal sunglasses with a camera, but they have Meta AI built inside and cost just $299. In 2025 alone, 7 million units were sold, which is more than triple its previous cumulative sales. In September 2024, Meta unveiled Orion, a prototype that looks like glasses but projects actual holograms right before your eyes, controlled entirely by hand gestures and your gaze. Apple also launched the Vision Pro for $3,500 in February 2024. Between the chip in the brain and the screen before our eyes, humanity expanded in 2 directions simultaneously over these 4 years. But that was just the beginning. The second clue, editing our biological source code. In December 2023, the US FDA approved the world's first CRISPR-based therapy called Casgevy, targeting patients 12 and older with sickle cell disease. It literally cuts and pastes a single letter of DNA. It's the exact same action as fixing a typo in a Word document, just happening inside our biological code. It costs a staggering $2.2 million per treatment, but that single shot provides a lifelong cure. A month after approval, beta thalassemia was added to the list, and within 4 years, this single drug spread to clinical trials across 8 countries. The next step is even wilder. In 2023, an American company named Verve Therapeutics began clinical trials to edit cholesterol genes directly inside the body. With one injection, the gene producing cholesterol in liver cells is permanently turned off. We are moving from extracting cells to fix them, to editing our bodies directly. In 2010, the J. Craig Venter Institute synthesized a bacterial genome from scratch. They didn't take it from nature. They coded it on a computer and put it into bacteria, which then replicated. Later, an NYU lab successfully synthesized almost all 16 chromosomes of a yeast cell from scratch. We aren't just fixing life anymore. We are coding and compiling it like software. This has crossed over into data storage too. In 2017, a Columbia University team successfully stored a movie, an operating system, and an Amazon gift card in just 1 gram of DNA. Now, Microsoft is working with a company called Catalog on a DNA data center project. Add aging to this puzzle. In April 2022, a lab in Cambridge injected Yamanaka factors into 53-year-old human skin cells for 12 days. The result? The cells reversed back to a 23-year-old state. David Sinclair's team at Harvard showed something even more fascinating, using these factors to regrow damaged optic nerves in aging mice. Altos Labs is now gathering massive talent, including Nobel laureates, to prepare for formal clinical trials. What was a sci-fi concept 4 years ago is now sitting on clinical preparation tables. But editing genes and delaying aging means nothing if we don't have the energy to power our future. The third clue, igniting a miniature sun on Earth. On December 5, 2022, at the National Ignition Facility in California, humanity achieved the impossible. They fired lasers at a tiny fuel capsule and produced more energy than was put in. 2.005 megajoules went in, and 3.115 megajoules came out. They broke a 70-year-old curse in fusion energy. They successfully repeated this ignition in July and October. Korea's KSTAR also held a 100 million degree plasma for 48 seconds in 2024. Private companies are rushing in. In May 2023, a startup named Helion signed a contract to supply 50 megawatts of fusion power to Microsoft, starting in 2028. Commonwealth Fusion Systems is currently building a demonstration reactor named Spark. Big tech is already placing financial bets on fusion electricity. And then there's the quest for room temperature superconductors. In July 2023, the LK99 paper from Korea flipped the world upside down, though it was officially debunked by December as a copper sulfide impurity. But the search continues. If a room temperature superconductor is ever achieved, U.S. power transmission losses will vanish, and the cost of fusion reactor magnets will plummet. The puzzle for infinite energy would be complete. Now let's look at the brain and the body being built outside of us. In March 2023, GPT-4 passed the bar exam in the top 10%. By October 2024, Anthropic gave Claude a computer use beta, allowing the AI to directly view screens and move a mouse and keyboard without human command. In March 2024, Devon arrived as an AI software engineer that completes actual coding work. Google released AlphaFold 3 in May 2024, reducing the years it took to find drug candidates down to mere days. By August 2025, GPT-5 was released as a fully integrated multimodal model capable of PhD-level math and reasoning. On the hardware side, Tesla revealed the Optimus Gen 2 in December 2023. Figure AI partnered with OpenAI and demoed the Figure 03 in 2025, folding laundry and running dishwashers next to humans. 1X began pre-orders for the Neo home robot at $20,000. Tesla announced they deployed 5,000 Optimus units internally in 2025, with V3 targeted for 2026. Now, remember the patient Alex? When he controlled the Optimus hand with his thoughts in 2025, we witnessed PhD-level reasoning AI, mass-produced humanoid bodies, and brain chips all converging in a single frame. There is one final foundation supporting all of this: quantum computing. In October 2023, Atom Computing announced an 1180-qubit quantum computer. But the real explosion came in December 2024 with Google's Willow. This 105-qubit chip proved that increasing qubits actually drops the error rate by half. It processed in just 5 minutes what would take a supercomputer 10 to the 25th power years to calculate. Microsoft revealed the Majorana 1 chip in February 2025. Because quantum computing threatens to break our current RSA 2048 encryption, the US NIST formally adopted post-quantum cryptography standards in August 2024. Now, organize these 9 clues and look at the picture. What happens when AGI handles quantum computers, accelerates protein and genome design, connects to BCI chips, and is powered by fusion magnetic traps built with room temperature superconductors? These 9 tipping points haven't just been happening independently. They started rolling forward together over the last 4 years. Is it a coincidence? Or is our generation standing at the absolute center of an inflection point? We'll follow the next clue when it appears. See you next time.